Hello, this is Ashish and welcome you to my YouTube channel. Today I'm going to show you how semantic search can be implemented using Pinecone vector database. So goal of this session, we'll just pass one query and try to find all the similar questions available in the data set semantically. So the tools which I'm gonna use here, like Python as a programming language, Databricks as a notebook, then sentence transformer for embedding library that uses BERT model internally, then Pinecone as a vector database, which implicitly using approximate nearest neighbor as the retrieval mechanism. So let's get our hands code dirty and do a code walkthrough. So here we go. So this is my table of content where I splitted uh, my solution in five different steps. First, the ingestion. Second, select embedding model and identify the vector size. Then third is creating index in the vector database. Fourth, abstracting the data into that. And fifth is uh, searching for the semantic sentences. So let's begin. And let's start from here. The very first thing you need to do is to install all the required libraries like sentence transformer, dataset, stick token, and Pinecone client. You can ignore LangChain OpenAI, so which I'm not using at present. Then this is one utility notebook for where I have created some pandas related retrieval uh, good to use functions. So this is not mandatory. So I run that because I want to use it. Then let's import all the required libraries. Now ingest data, I'm using a Quora dataset from the Hugging Face library. And for that purpose, I already imported this function. So let's call this load dataset function from Hugging Face where I pass the Quora as a path parameter and then 5000 vectors or the records out of it. And then, so let's run it as a first step. It's running well and it's completed. Let's check the record, first record. Yeah, it's there. We have questions, then ID, text, and is duplicate um, um, columns against it. I would say, yeah. So then what I'm gonna do next step, uh, I'm just fetching the questions. So this is a couple, the pair of the questions available under the text column. So I'll just fetch that because the rest all things we don't require. So let's do that and um, run them and extract it in our question dupe. So that is what you get. So it may contain the duplicate records also. That's why I put it as dupe. So now let's second step is to remove those duplicate records by using a set keyword in Python. So and then again you need to convert data structure to list. And let's do that. So duplicate I remove. Before it was 10,000, now it's 9859. So 141 duplicate records being identified. Now let's move to step two. So there's embedding model selection. So I'm using mini LM L6. That's a quite strong sentence transformer or say the embedding model available in sentence transformer library. So that's what I'm instantiating it. Then, then next step is just to check the vector size. So this is a very important step because every embedding model are having certain vector size, and that size should match with your index dimension size. If it won't match, it will throw an error. So there are multiple ways. So I have already specified here three different ways through which you can check that. One is via embedding model object. Just check that and you will find here 384 under word embedding dimension. Second is directly calling get sentence embedding dimension method. And the third way is to query vector shape. So you just create the query vector by using embedding model and code function, and then check the shape of it, and you get the 384. So that's how you can find it out. Now our third step is to create the index in a vector database. Vector database, here we are using the Pinecone console, like the way you can see here. This is what my Pinecone console, and as you can see right now it is showing 1,000 records. That means I have to um, uh, delete the existing index because I'm on a free tier, and the maximum indexes you can create inside a free tier is just one. So I need to check if it is exist. If it exists, I need to delete it, as I can you can see in line number 11. And once it got deleted, then I'll again check. So I don't find any name because I am emptying this list for existing indexes, and then create our new index. So while creating a new index, I'm using a object from the Pinecone. From here, where I passed Pinecone API key, which I have stored as a constant inside my utility notebook, and then I create a pod spec with my environment name. So this is the default GCP starter environment name available in the Pinecone database. So I'm using that, and then give my uh, uh, one index name, uh, like semantic search index. Okay, so let's do that and run it. So it should create. So as you can see right now, already it's present, so it will delete that and recreate it. So this vector C, from 1,000 it becomes 0. So that means it's working. So here also you can see index semantic search index is deleted and ready to create a new one. Then it has created a new one. So right now there is no vector available, as you had seen in the database and also here. So now move to step 4 to add records into it. So we do the upsert operation. Upsert is like the combination of update and insert. So if the record is not available, it will insert it. Else, if record is available and it's changed, it will update it. Otherwise, it won't do anything. So that's what we are going to do here. And another important thing, when you perform a upsert operation, it's always preferable to do it in batches to save time and effort and make the things faster. And that's what we are doing here. So batch size, I just put 128 vectors at a time. So for that purpose, I'm just looping it through and creating a batches. So this is where check uh, what will be the last record for my batch in each iteration, then putting the same batch in ID, all the IDs in a list, then metadata that contains the text in a list, and then um, uh, then we are encoding this into the using embedding model to encode that. Yeah, and so that's how we create different vectors in batches, and then finally these list you zip it through so that a single record means a record will contain everything, and then you call this upsert function from index uh, uh, the object, and pass these records as value for the vector parameter, and then um, see, by calling a describe index stats, you can see the stats how it looks like. I think now it's done. So let's see now what we'll do because it takes a while to update the output. So now it's 1,000. So same thing you can see again here. So if I just call this particular function just to see the latest count, and yeah, it's 1,000, so it's working well. So now it is 1,000, so it's fine, it's working. So all records got upserted. Okay, now the last and fifth step, where we query um, our vector database, a Pinecone database, to find to do similarity search in terms of semantic or the context. Okay, so this is our first question. Which country has the largest population in the world? So and then we create a query vector. This is embedding model encode. That's how we create, pass our query as a parameter and then convert it into a list. Okay, and then call query function of the index object and pass this query vector to a vector parameter. Then top k a value will decide how many values you want to be returned here and whether you want metadata or not. That also you can set by using a include metadata parameter. So let's run it. So as you can see, it is coming in a dictionary sort of format, and that is um, good but not as readable as in data frame. So that's why I have created one utility function inside a gurg-utils. That's with my family name. And when I run this, you can see it in a better way, so it's more readable. So now it's quite evident none of these written results are giving us a good similarity score. That means they are not at all similar because all of them are less than 0.50 or less than 0.60. So none of the sentences are contextually similar to what we have passed. So now we'll uh, pass another query uh, query 2 that says, will the USA be the country with the largest population ever? So let's see what it returns. Okay, similarly, we run it again. And wow, so now there is one record that is having a 0.692546 score. That means it's a very good score. So that ensure this one is for sure more or less very much similar to what we have passed. So will the USA be the country with the largest population ever? And could USA ever become more populous than China or India? Because as we know, China and India are the most top two most populous country in the world. So both gives us the same meaning, and it is giving us the right result. So we can ignore rest of the full by filtering it out. So we can filter in the data frame all the records which are more than 0.65 similarity score. So it will return us could USA ever become more populous than China or India? So that's our final output. And if you don't want to use data frame in a normal way, also you can do by converting our output to dictionary and then put a condition here, and this will give you a result in a very much a list form. Um, so that's all, and that's it how we do semantic search in Pinecone database. And I believe it's definitely help all those who are learning Gen AI and data science for um, their career upliftment or for their aspiration in a AI world. So for whatever reason, so good luck, and that's all for today from my end.